That alone should beg the question, why? And the reason, of course, two reasons. First, two foundational technical reasons. The first reason is that computing went from being a retrieval-based file retrieval system. Almost everything is a file. We pre-write something, we pre-record something, we draw something, we put it on the web, we put it in a file, and we use a recommender system, some smart filter, to figure out what to retrieve for you. And so we were a human pre-recording and file retrieving system. That's what a computer is, largely. To now, AI computers are contextually aware, which means that it has to process and generate tokens in real time. So we went from a retrieval-based computing system to a generative-based computing system. We're going to need a lot more processing in this new world than in the old world. We need a lot of storage in the old world. We need a lot of computation in this new world. And so that's the first part of it. We fundamentally changed computing and the way how computing is done. The only thing that would cause it to go back is if this way of computation, this way of computing, generating information that's contextually relevant, situationally aware, that is grounded on new insight before it generates information, this computation-intensive way of doing computing would only go back if it's not effective. So if for the last 10, 15 years while working on deep learning, if at any single moment I would have come to the conclusion that you know what, this is not going to work out. I think this is a dead end, or it's not going to scale. It's not going to solve this modality. It's not going to be used in this application. Then, of course, I would feel very differently about it. But I think the last 5 years has given me more confidence than the previous 10 years. The second idea is computers, because it was a storage system, it was largely a warehouse. We're now building factories. Warehouses don't make much money. Factories directly correlates with a company's revenues. And so the computer did two things. Not only did it change the way it did it, its purpose in the world changed. It's no longer a computer, it's a factory. A factory is used for generation of revenues. We're now seeing not only is this factory generating products, commodities that people want to consume, we're seeing that the commodities are so interesting, so valuable, so to so many different audiences, that the tokens are starting to segment like iPhones. You have free tokens, you have premium tokens, and you have several tokens in the middle.
Yeah.
And so intelligence, as it turns out, it's a scalable product. There's extremely high intelligence products, tokens that are used for specialized things. People be willing to pay, the idea that somebody's willing to pay $1,000 per million tokens is just around the corner. It's not if, it's only when. And so now we're seeing that the commodity that this factory makes is actually valuable and is revenue generating and profit generating. Now the question is, how many of these factories does the world need? How many tokens does the world need? And how much is society willing to pay for these tokens? And what would happen to the world's economy if the productivity were to improve so substantially? What would happen? Are we going to discover new drugs, new products, new services? And so when you take these things in combination, I am absolutely certain that the world's GDP is going to accelerate in growth. I'm absolutely certain the percentage of that GDP that will be used for computation will be 100 times more than the past, because it's no longer a storage unit, it's a product generation unit. And so when you look at it in that context, and then you back into what does NVIDIA do, and how much of that new economics, new industry would we have to benefit to address, I think we're going to be a lot bigger.